Hello again, this is Mrs. Nakayama, and today's lesson is 6.4 Graphs of Polar Equations. I think they're fun because they're different than what you've ever seen before. Please keep in mind that I have made this lesson much easier for you in MyLab Math. Not only does MyLab Math make it easier than doing it by hand, but I'm even made it easier, so I hope you'll pay attention and take some good notes while you watch this video. We are going to talk about two different methods of graphing polar equations. The first one is point plotting, and the second one is making sure that you recognize the equations so that you'll know what the graph is going to look like. All right, so to refresh your memory, all right, remember that a polar equation is an equation who has the variables r and or theta. Okay, they don't have to have both. Just like a rectangular equation is one that has x and or y. It doesn't have to have both of them. Okay, and the graph of that polar equation is any set of points that satisfy that equation. Again, same thing we do with rectangular. Any ordered pair x, y that satisfies that equation is a point on the graph. Okay, any point r theta that satisfies the equation is going to be on the graph. And we've talked about these polar grids in the previous lesson, okay, that you mainly got to remember where 0 is, 0 and pi over 2, 3 pi over 2, halfway between is your pi over 4s. I mean, you've got to know them all, but just a quick refresher. Okay, so I'm going to present several different types of graphs to you. If you want to know more about them, I will be happy to talk to you more about them, so please let me know. The first and probably the simplest one are the graphs of circles. Okay, and circles have the equation of r equals a cosine theta or r equals a sine theta. Okay, when you look at these equations, y'all, actually I'm going to write with this. R equals a cosine theta. Okay, cosine is which coordinate, x or y? You know it's x, and the sine is y. Well, look at where my circle is. If it's cosine, my circle is on the x-axis. If it's sine, my circle is on the y-axis. Positive is going to be on the right, negative is going to be on the left. Positive is going to be up, negative is going to be down. It's just some key things to help you remember and distinguish them. But you have to remember those equations. So I would encourage you to write them down every time you do a problem in your homework. All right, the next type we have is something called limousin, which is the French word for snail. Okay, now these are the different equations that you got to be familiar with. Oopsie. R equals a plus b sine theta. Oh, that's kind of funny because that one right there is supposed to say cosine. Okay, so act like this right here says cosine. So r equals a plus b sine theta or r equals a minus b sine theta. And then you can have a plus b cosine theta and a minus b cosine theta. And these are all determined, okay? How do you decide which of these it is? You look at the ratio between a and b. Okay, you all need to remember this. So if a is less than b, if that ratio, if a is less than b, that's kind of easier to me. Another way of saying that is a, let's go with a different color. If a is less than b, which is the same thing as what I just highlighted, then you have to remember that it's a limousin with a loop. There's lots of L's. A is less than b, it's got a loop. All right, the next one is if a is equal to b. Okay, again, that says a over b equals 1. Well, you could remember that a equals b. And if a equals b, then it's a heart-shaped and it's called a cardioid. Okay, and these last two, we don't distinguish between them. I'm not going to make you distinguish between them. One has a dimple and one doesn't. But more importantly, there is no inner loop, and that is if a is greater than b. Okay, so you're paying attention to these numbers in front. It has nothing to do with the sign, just the number by itself and the coefficient in front. And again, y'all, the sign or the cosine is going to tell us where the fat part of the graph is. And I'm going to talk you through that when we do some problems. All right, the next curve we have is something called a Rose curve. Okay, those equations look like this. R equals A sine n theta, or R equals A cosine n theta. Those are our Rose curves. Now, what you have to pay attention to is n is very important in this problem. Okay, if n is even, then the rose has 2n petals. So you double it to find the number of petals. If n is odd, then the rose has that many petals. So if you look here, this says 2 theta. 2 times 2 is 4, so it has 4 petals. This says 3 theta. It's an odd number. It has 3 petals. 4 theta. 4 times 2 is 8 petals. And 5 theta has 5 petals. So you got to pay attention to that n in front of theta. The A tells you, it shows you in each of these pictures, A is the petal length. Okay, so here's A right here. This is A. That's the length of the petal each time. Okay, up here they're showing it to you right there. Okay. The other thing that I want to point out to you that you want to pay attention to is where it starts. So this first graph here, the petal starts in between. And this graph, the petal starts on the x-axis. This one's on the x-axis. This one is not on the x-axis. Now, I can tell you exactly where it starts and how to know that, but what you have to know is whether or not what's going to cause it to start on the x-axis. So if you look at those equations, okay, take a second, pause, because if you can remember now, life's going to be a lot easier, okay? Pick it back up. What makes the difference in where the petal starts is the trig function. So if it's cosine, then it starts on the x-axis. If it is sine, it starts off of the x-axis and in the quadrant. And again, I can talk to you more about where it is, but I don't think you have to know that right now. All right, and the last group that we're going to have before we go do some examples is something called lemniscates. A little bit of a hard word to say. The key to the lemniscate, y'all, if you look at it, okay, notice that it has exponents in it. And more importantly, where are you going to see that exponent? And what you need to notice is that r squared, because a is going to be a number, and you're not going to know, okay? So if you see r squared, it's a lemniscate, which looks like a propeller, okay? And remember, I just talked to you about where it starts, okay? And the sine function always starts off. It's going to always be actually halfway between. It will be symmetric to the pole, okay? And if it is the cosine, just like what we talked about before, it will start on the positive x-axis. That will be its first leap. And notice the cosine graph is symmetric to the polar axis, the pole, and theta equal pi over 2, which is right here, okay? So some key things that you have to remember. This number in front of it both times is a squared number. So to find the petal length, you have to take the square root of it. But again, we'll do some together so you'll see. All right, so we're going to go start off doing it with the point plotting method. And the point plotting method, y'all, we are first and foremost, when we can, we're going to identify the shape. Then we're going to complete this table over on the right, and then we're going to sketch the graph. Okay, but when you do this, you are picking convenient values of theta to make it easy to find r. That's what makes this method not so bad. I don't know why I did that. Stop. Okay, so when you look at graphing r equals 3, you might not know what that looks like yet because I didn't talk about it, but I have my convenient values of theta, okay? And in case you can't tell, those are all the ones that are on the axes, okay? But more importantly, if I'm graphing r equals 3, that means that no matter what theta is, r is always 3. So on my graph, from the pole, I'm going to go out 3 in every direction. So you need to know and recognize, and we kind of talked about it in a previous lesson of changing it to rectangular form, but that's the graph of a circle. Okay, x squared plus y squared equals 9 because you square the r. Okay, how about graphing theta equals pi over 6? Well, if theta equals pi over 6, and then no matter what, theta is pi over 6, but r can be anything. So I could say -2, -1, 2, 4, 7, anything. And when I graph those, they're going to all be on the same line. So you can see the dots there. I graphed each of those points. Pi over 6, -2 is right there. Pi over 6, -1, pi over 6, 2, pi over 6, 4, and pi over 6, 7. And then you connect them. But most importantly, these are two other equations that it will serve you well to memorize. R equals 3. The radius is 3 of that circle. Okay? Theta equals pi over 6 is a line. Okay? Those are twos. Rather easy one. Let's look at these. Now, we just talked about earlier, R equals 2 minus 4 cosine theta. Okay, so when you have a number plus or minus a trig function, guys, stop. When you have a number plus or minus a trig function, then that is going to be a limison. Okay, so then you got to go look at 2 and 4. You do not worry about the negative, y'all. You only look at the 2 and the 4. 2 is A and 4 is B. In this case, A is less than B, so that less than means I'm going to have a loop. Okay, I'm still going to go fill out my chart. So when we say we're picking these convenient values, y'all, think about your unit circle and what these numbers are. Okay, what these values are at these places. At 0, the coordinates are 1, 0. At pi over 2, at pi, and at 3 pi over 2, and then back to 2 pi. And remember that the first number represents cosine and the second one the sine. So if I have to find 0, that's this coordinate right here. So I'm doing the cosine. So every time I'm going to use the first coordinate. So this is 2 minus 4 times 1, which is -2. And you can write it out if you want to, plot it, make a table. Okay. Pi over 2, cosine is 0. So if I 2 minus 4 times 0 is going to be 2. And then at pi, it's -1. So 2 minus 4 times -1 is 2 plus 4, which is 6. At 3 pi over 2, we're going to have 2 again. And at 2 pi, we're going to have the same thing as 0. So when I plot those points, but the way I connect them, I have to have a loop. So it looks like this. So I plotted all those points. And then let's see if I can trace it for you. Not so well, but I start at the pole. And I come in and make my loop, and then I'm just connecting all of these points. And that's how you draw it. Okay, let's look at graphing r squared equals 9 times the sine of 2 theta. Okay, I told you to pay attention whenever r is squared. So the fact that I have that squared right there tells me it's a lemniscate. A lemniscate is that propeller looking thing. And that means I don't have to fill in the chart because I know it's a propeller. Okay. I know its pedal length is the square root of 9. Sine means it's starting halfway in between at pi over 4. And that's my graph. So I just went out 3 on each. 1, 2, 3, third ring, halfway between the pole and that one. I will say, if there was a negative in front of here, y'all, it would just be over here. Okay? I don't know what I'm doing. Sorry. All right. And the cosine, remember, looked like it went back and forth this way. And if it was a negative, it would go up and down instead of left and right. Okay. So that was doing it by hand. This is more of what your homework is going to be. And if you pay close attention, y'all, you will find out how easy this is going to be. So r equals 2 cosine theta. It's a circle. Okay? You can tell by looking at all those, but it's good for you to know that it's a circle. Okay? You can put in a point and figure it out that it's going to have the point 2, 0. But more importantly, there's no negative here, so it's the positive cosine. Positive cosine is x. So which one has it? So this is on the y, not going to happen. That's a negative x. That's a positive y. That's a positive x. So my answer is going to be D. All right, look at number 4. Graph the polar equation. Okay, so if I look at it, all right, you can see all the graphs down here. That one has a loop, so you do have to pay attention. All right, we know it's a limison, but we're going to go look and see about A and B. And I have 3 and 3. So A equals B. That means it's a cardioid. Okay, it's got the sign, so that means it's going to be on the y-axis. And if it's on the y-axis, I can knock that guy out. I can knock that guy out. And it's minus 3 times the sign, so it's on the minus y-axis, which means my answer is D. Okay, this one we're going backwards, so we got to know a little bit more about it. All right, but it is a circle, and that circle is going up, positive sign. Okay, it is a circle going through. I don't know where it went. 0, 3. As I just said, it goes up and down, which means it can't be cosine. Is it 3 minus 3 or is it 3 sine theta? Well, the plane circle is just 3 sine theta because this first one would be a cardioid. I think we just graphed that. Yeah, right there. So that's what that one would look like. Okay, number 6. Graph R equals cosine. Nope. Graph R cosine theta equals 10. So R cosine theta equals 10. You were like, that's not like much of what we've seen. But you should remember from the last lesson that R cosine theta is x. So which one of these graphs looks like x equals 10? X, well, clearly these aren't, because these are y equal. That's D is negative 10, so it has to be A. So I'm telling y'all, if you just know a little bit about it, these are not hard. Okay? Last one. We have a rose, okay? And the equation for my rose, I know that it starts at the, it starts at the, on the x-axis, which means it's going to have cosine. That's really strange. It has 3 petals, and that means that in front of my theta is going to be a 3. Well, they all have a 3, so we didn't really need to know that. All right, what is the length of the petal? 1, 2, 3, 4, 5. So I'm going to have a 5 in front. That is my A value. So that means that knocks out this guy and this guy. So, and the last thing you got to remember is it's sine or cosine. Well, it starts on the x-axis. Really bad draw. So if it starts on the x-axis, it's got to be the cosine. Okay? So, not very hard if you know some idea about these equations and their shapes. And I have put a 1-page summary in Schoology for you to have all of this information at one place. I would encourage you to print it off. Thank you so much for watching, and y'all have a great day.